right, good afternoon, everyone. We still have a couple of participants filtering in, so I'm just going to give everyone a couple of seconds before we get started. All right, greetings, everyone, and thank you for joining us today. Welcome to our second annual Field Inclusive Week. We are excited for you to meet our panelists momentarily. My name is Kayla Stukes. I use she, her pronouns, and I am a current PhD student at North Carolina State University pursuing my degree in forestry. I am also the executive assistant of Field Inclusive, a young nonprofit working towards amplifying and supporting marginalized and historically excluded biologists and researchers who professionally work outdoors. Just so you're aware, today's webinar will be recorded, and recordings will be posted to our YouTube channel throughout the week, so be sure you follow us there for easy access to these recordings. Shortly, I will introduce our panelists, but first, I would like to give a special thanks to our sponsor of Field Inclusive Week 2024, the Nature Conservancy. Thank you for coming on board as our sponsor for the second year and for being dedicated to promoting and supporting a more inclusive outdoors. It is through organizations like yours and the many individuals who donate to support Field Inclusive's mission that we can continue our goals in raising awareness when it comes to social field safety issues by hosting events like Field Inclusive Week, as well as providing financial support to marginalized and historically excluded individuals who professionally work outdoors. Now, without further ado, it is my pleasure to introduce our speaker for today's discussion. Taylor Saucier is a freshwater fisheries biologist and a master's student at the University of Arizona. Her research is focused on developing techniques to rear and spawn a native Arizona/New Mexico fish species in captivity, the Sonora sucker. Her past experiences in working in fisheries conservation and management, as well as aquaculture, have inspired a passion for conservation aquaculture. A huge welcome and special thanks to Taylor today for agreeing to share her time and experiences with our audience members. Audience members, please feel free to submit questions for our speaker for the Q&A portion, which will be towards the end of our discussion today. Now, without further ado, I will pass it off to Taylor. And again, just to reiterate for our audience members, as you listen to the conversation, we invite you to please place your questions in the Q&A section of the webinar for our panelists to answer during the Q&A portion. All right, without further ado, take it away, Taylor.
Okay, hi everybody. My name is Taylor Saucier, and today I'll be talking about finding success through failure. So let me get my slides all ready. Oh, there we go. But before I start, I want to say thank you to Field Inclusive for putting on this amazing and informative week. They do a lot of great work, and I'm really happy and proud to be a part of this. So I'll start off with introducing myself. I'll talk about failures I've encountered in my career path, go over some background on the topic of failure, share 3 stories from my experience out in the field, and then share my experience with failure in my current research. And then I'll talk about final takeaways. So who am I? Well, I want to introduce myself before talking to y'all. I found in the past I would just share my professional identities like I was reading off of my resume. But people are so much more than just what we do for our jobs. So with that being said, I'm Taylor Saucier, and I'm a pet parent to 2 cats and a dog. People love cute animal pictures, so I figured I would introduce my pets as well. Leslie was the first pet I got as an adult when I was a sophomore in undergrad. Then I got Mango, who has the adorable underbite. And last but definitely not least, I got Peggy, who has 3 legs and no tail. So I have bipolar and ADHD, something that has caused a lot of failures throughout my career. I use she, her pronouns, and I'm also bisexual. So I'm also going to share a little bit about my professional background because it is also full of what some may consider failures. My career in this field started at Mississippi State, where I got my bachelor's degree in wildlife fisheries and aquaculture. My senior year of undergrad, I really started to struggle with my mental health. Up until then, I had had a really great support system, which was my group of friends I had made in college. But they had graduated and I was on my own to cope with my then undiagnosed mental illnesses. So I started to seek out therapy, where I was diagnosed with bipolar disorder and put on medication. But before I found a medication that actually helped me, I was struggling a lot with depression and mania. I stopped trying in my classes and I even failed one of them. I was terrified that that failure, a literal failure, would keep me from graduating. Luckily, the class that I failed was an elective, and I was able to take another elective my last semester to fulfill the requirements for graduation. After graduating, I accepted an offer to go to graduate school at Ball State University. My research was on creating a machine learning algorithm in Program R to identify age at maturity from fish otolith measurements. I had done well, and I had even enjoyed the little bit of experience in the course I had taken in undergrad using Program R. However, I was not prepared for the advanced level of mathematics I would be required to learn. Between the stress of feeling in over my head in my courses and my research, the isolation of being in a new city alone in the middle of the pandemic, and my mental health medications starting to stop working, I decided it would be best for me to drop out. So in March of 2021, I dropped out of grad school and I moved to Alabama, where my boyfriend at the time lived. I worked several minimum wage jobs in the service industry for about a year before I finally found a job using my degree. I got a job as a fisheries scientist at an NGO in Arizona, where I had several failure stories that I'll share with you in greater detail later. And then one day while I was browsing Texas A&M job boards because I was bored, like we all do, I saw a master's research position posted that really excited me, and I felt like I was actually perfect for it, which leads me to where I am now, at the University of Arizona, pursuing my master's degree for the second time. So I'm currently about halfway through my master's, where I'm developing techniques on how to rear and spawn the Sonora sucker, which is a native Arizona and New Mexico fish species in captivity. This species has not been successfully reared and cultured in captivity before, and this past year has been full of failures. Even though we had disease outbreaks and water quality issues that caused lots of fish mortalities, we've been able to learn a lot from these failures and are getting closer to success each time. I've had a lot of failures in my life so far, but I've learned to accept and learn from them. I wanted to share this quote from the poet and activist Nikki Giovanni, who said, "Mistakes are a fact of life. It is the response to error that counts." I found the best response to mistakes or failures is to learn from them. So now that you know a little bit about me, let's talk about fieldwork. Fieldwork is a lot of different things. Fieldwork can be fun. You get to go out into nature and often get to see or even interact with wildlife. And for a lot of people in the natural resources, these are the things that they enjoy most about their job. Fieldwork is essential. To properly manage and conserve natural resources, we must be able to gather information about them in their natural environment. But ask anyone who has just finished a field season, and they will tell you, fieldwork is tiring. Fieldwork can also be dangerous. There are many different types of dangers you could encounter out in the field, from environmental to social. And it's easy to focus on the good aspects of fieldwork, but it's necessary to pay attention to the negatives as well. Science is full of trial and error, and fieldwork is no exception, but failures in the field can lead to dangerous situations since it's an uncontrolled environment. You can't prevent all failures, but through preparation and awareness, you can reduce their frequency and learn how to safely react when they occur. Thus, turning your failures into successes, or at least into a good field story. So, the first story from my fieldwork that I'm going to share with you, I've entitled Lost in the Desert. This story takes place in Arizona. So, there's our little Arizona. About 2 hours north of Phoenix, near a man-made reservoir called Horseshoe Reservoir. There's a small perennial creek called Lime Creek. And the road to get there is very mountainous, winding, and unpaved. The road is so difficult to traverse that there was an option in the project contract to take a helicopter, but the project lead decided that we could drive and hike in to save money. The drive started out with beautiful views, and we even got to see an elusive Gila monster. And if you haven't seen one of these before, they're the cutest, most dangerous little things you'll ever see, and they often are just running away from you. As we got closer to the field site, the road conditions worsened. These roads are dangerous when dry, and during our drive, we got a brief rain shower. The project lead and driver had been trying to sample this creek for months, but had been unable to for various reasons, so he decided that we would continue on. After putting on my wading socks and boots, we were ready for the hike to survey Lime Creek. I took this cute selfie before starting the hike, and man, am I glad that I did after what happened. We started on our hike to find the flowing portions of the creek. We had our packs loaded with all the gear we needed to do our fish survey. We had one water bottle and one Gatorade each to get to the wet portion of the creek where we would be able to refill our water with the filter that we brought. After hiking miles in the desert sun, we finally found some water. But it wasn't really the kind of water that you want to filter to drink, and it was not enough water to survey for fish. At this point, I had finished drinking my one water bottle, and I was starting to get a headache and feel a little lightheaded. So I told my crew that I wasn't feeling well, and we found a little bit of shade, and I started drinking Gatorade. After sitting there for a couple of minutes, I decided I would not be able to safely continue hiking to the survey location, which was about another 5 or so miles away. So the group decided to continue, and I was to return to the truck where there was plenty of fluids. By this time, it was the middle of the day in July in Arizona, so temperatures were well over 100 degrees. There was very little shade, so I would find big rocks and crawl under them to rest. We only had one GPS unit, and they needed it to find the survey location. So I headed back to the truck, attempting to go back the way that we had came. But in my dehydrated state, I missed a turn, and things started to look unfamiliar. Not only was I dehydrated and overheating, I was lost. There wasn't signal, so maps on my phone wouldn't load, and even if there was, I didn't know exactly where the truck was. But during one of the breaks, I remembered that photos have GPS locations associated with them, and I had taken a photo at the truck. The photo map wouldn't load any features, it was just a white grid with the photo locations. But I found that I could use it to navigate by taking a photo and then comparing the location of that photo to the photo that I took at the truck. And you can see here, this is an actual screenshot from my phone with all the photos that I took along the way trying to get back to the truck. So I survived, obviously I'm here, after taking lots of photos of the ground to locate myself and check that I was headed in the right direction. I finally made it back to the truck where I was able to hydrate and cool down in the shade. About an hour or two later, my crew returned after having found the survey spot to be dry. We went home for the day, having gotten no research done, but a lot of risks to safety. So what did I learn from this life-risking failure? Before you go out into the field, it's important to hydrate. It's so important for your health to be hydrated, and it's so difficult to find the time to properly hydrate when out in the field. So making sure that you start the day already hydrated can help. How much water you should be drinking and bringing depends on a lot of factors, but a general recommendation I've seen is 1 liter for every 2 hours of moderate exertion in moderate heat. In the story I told, because we were carrying heavy packs and hiking long distances, it was probably moderate to high exertion in extreme heat. So bringing 2 bottles of fluids was definitely too little. Another thing that we did wrong in the situation was to leave a person by themselves. Many things could have happened to me to make it to where I was unable to get back to the truck. I could have passed out from heat exhaustion, gotten bitten by a rattlesnake, or tripped and broken something. And since I was by myself, there would have been no one to get help or to assist in any medical emergencies. What if, like us, you have a crew of 3 people and can't split up without someone being by themselves? Well, in that case, you should prioritize safety. Looking back, there were several times that we put getting the work done ahead of our personal safety. The field site will still be there another day. Your life is not worth the data. And lastly, bring more than 1 GPS device when going out into wilderness areas. This can be useful if you have to split into groups or something happens to your main GPS. I also recommend trying to get access to a satellite phone as well, so you can call for help in emergency situations. So my second story, this one I have entitled Overboard. I used to do field work on the Colorado River near Lake Mojave. We used a boat to deploy and collect pit tag antennas that scanned tag fish. While this area was very popular with tourists, there was no cell signal. This means that when things went wrong, you were on your own to decide how to solve the problem. During my time working on this project, we had many things go wrong and often prioritized getting the work done over our personal safety. And this story is another example of just that. So while filling up the boat with gas at the marina, my coworker rested the gas cap on the edge of the boat. I remember thinking, that's going to fall in. but I dismissed it as me being overly anxious and paranoid, as I tend to be. While the gas cap did fall overboard and sunk down to the bottom, the gas cap was visible, but it was 20 to 30 feet under the water. It felt like a bad idea to have a gas tank without a cap, and we would have had to drive about 45 minutes into town to the hardware store that might not even have a replacement. So my coworker volunteered to swim down and get it. She was an experienced swimmer and thought it would be fun to dive to the bottom. And so while it was really hot outside at the time, the water was significantly colder. As you can see from this photo, she was very quickly able to dive down and get it. So we were able to turn this field fail into a field success, but it was at the risk of my coworker's safety. Not only was there a risk of shock from the stark temperature change, there was also risk involved with diving in a heavily trafficked motorized boating area. We tried to minimize that risk by turning our boat off and tying it to the dock away from where she was diving. But you can't control every situation. There always could have been another boat, and I couldn't have stopped them fast enough. A lot of things could have gone wrong. Luckily, it didn't, but that's just something you have to think about. So here are some of the thoughts I have about this. This was my first job out of undergrad, and I was very eager to impress and do good science. Whenever a failure would happen, I would be so eager to fix it that I would forget to think about the safety of myself and my coworkers. I think a lot of people in our field are willing to tough it out for the sake of the research, that we often put ourselves in harm's way in the process. There are ways to turn failures into successes that don't risk safety, but they might not be the most apparent or easiest solutions. So if you have the time, take it to figure out the best course of action. My third fieldwork failure story, I have entitled Out of Gas, Sort of. So for a little bit of background, I did not grow up driving boats. It was something I was taught how to do once I started taking fisheries jobs. My experience with motorized boats had been very limited until I got a job where I had to operate a boat for a week every month. Operating a boat comes with a lot of new skills and a lot of new safety hazards. I was briefly instructed on the basics like trailering, launching, and driving the boat, but I didn't know much more than that. So while working on the Colorado River, we would deploy pit tag antennas on shallow banks in coves for about 24 hours, and then we would retrieve those antennas to collect the data and replace the batteries. We had retrieved some of the antennas at this point, but still had about 10 more that we needed to check. This day in particular was very windy. While we were navigating a cove, the boat stopped running. During normal conditions, this wouldn't have been a big issue, because there's normally lots of recreational boats on the water, and we had a radio on the boat. But due to the bad weather, there weren't a lot of boats out, and since we were in a cove, the canyon walls blocked our radio signal. While my coworker was using a net to keep us from crashing into the nearby rocks, I started trying to figure out why the boat stopped running. I quickly noticed that we were out of gas in one of our gas tanks, but we still had a full tank of gas in the other tank. One of the things my coworker and I did not know about the boat that we were operating was how to switch the gas from one tank to another. But how hard could it be? Our boat had a three-way valve that I knew needed to be turned to switch the flow from one tank to the other. But of course, it wasn't as intuitive as I thought it would be. For those that aren't familiar with how a three-way valve works, just like I wasn't at the time, here's a diagram showing the various positions. Keep in mind, we did not have access to this diagram at the time. The valve was set to pull from tank 1, as shown in the green rectangle. So logically, we thought that we should point the little arrow to the tank 2 side, shown in the blue rectangle. But as this diagram shows, that actually closes the inlet. So after that didn't work, we resorted to trying every position, as one would do in a situation. But another thing about boats is that when you run out of fuel, you have to use a squeeze pump to manually get the fuel in the line to prime the engine before starting it. So each time we were trying a new position, we quickly would pump the fuel in the line before trying to start it. And then we would move on to a different position if it didn't start. I later learned that this boat requires a good bit of priming before it would start, probably because it's old and there's holes or something in the line that reduced the pressure. So the couple of times that we were squeezing it before switching the valve to try a different one was probably not enough. We were finally able to flag down another boat and got towed back to the marina, where we were able to fill up tank 1 with gas, prime the engine, and get the boat running again. Once we got back in cell service, we were able to look up a 3-way valve diagram, which I saved to my phone for future reference. So what did I learn from this mishap? Well, it's important to be properly trained on all equipment you'll be using, especially on what to do in emergencies. When you know your equipment well, you're better able to respond to the situations when things go wrong. If we had been less panicked, knew which direction to turn the valve, and that priming required a bit of time for this boat, we would have avoided a risky situation and we would have been able to get our work done a lot sooner. So to review, from the first story, I learned to prehydrate, bring more fluids, use the buddy system, prioritize safety over data collection, and bring multiple GPS devices. From the second story, I was reminded about prioritizing safety. It's very easy to talk about how important it is to prioritize safety, but when you are in the moment and you have those pressures to get work done, it's really hard to keep that as the first thing in your mind. So it took me a couple times of being out in the field to learn how important that is. And then also to know to weigh your options. And then for the out of gas story, I learned the importance of having proper training and knowing your equipment. So now I'm going to go into a little bit more detail about the failures I've encountered so far during my research. My current research does not involve a lot of field work, but still has plenty of failures. My research goals can be broken into two simple objectives: survival, can we keep these fish alive in captivity? And reproduction, can we get these fish to spawn in captivity? I've spent the last year working on the first goal, survival, and it has been a lot trickier than I originally thought it would be. A little background about the fish species I'm researching. The Sonoran sucker is a medium-sized fish in the sucker family, Catastomidae. It's a generalist omnivore that is found in stream habitats where it utilizes riffle and pool mesohabitats. It is not a threatened or endangered species and is not really a typical game species. Lastly, there has been very little research done on this species. We collected 48 fish from the canals in Phoenix and put them in 15 circular tanks in a recirculating aquaculture system. Every day, we would check various water quality parameters and visually inspect each tank to look for mortalities. The first fish didn't die until 2 weeks after collection, but then there were more mortalities. After the first couple of mortalities, we decided to net some of the fish to inspect their condition. And while most of the fish looked normal with minor symptoms, here are some of the worser conditions we found. So what was causing this? Well, we swapped that hemorrhaging spot on the live fish that I showed you in the last photo, and we brought in one fish that appeared like it was going to die, and one fish that was already dead for testing. The lab confirmed it was a bacterial infection called Aeromonas hydrophilia. Aeromonas is widely found in aquaculture, but can cause significant mortality with predisposing stressors. It's kind of like pneumonia in humans, how you don't normally get it if you are healthy, but once you are stressed or are already sick with something else, then you are susceptible to getting it. So we identified 5 potential stressors post-infection that we were going to focus on and try to improve. The first is flow, then fiberglass, then water quality, then density, then feeding. So the first one I'm going to talk about is flow. Our original water inflow setup had the water dumped straight into the tank. This means that the water mixed very little and had no flow. And that was how it was set up when I just got to this greenhouse that was previously used for a different fish species. And while it might have worked for the previous fish species, when we got our fish, it appeared to be causing a problem. So after we built a manifold to direct the water in a circular motion along the outer edge, we created some flow in the tank, which formed a slight vortex to more effectively remove the solid waste. Additionally, since these fish occupy streams with flow, the moving water more closely mimicked those conditions as best as possible in a circular tank. The next potential stressor I'm going to talk about is fiberglass. We started to notice that the fish had small wounds on their ventral sides, mainly on their fins. This is likely due to them swimming on the bottom of the tank and repeatedly irritating the area with fiberglass contact. While fiberglass tanks are really commonly used for fish that dwell in the water column, we learned that it is necessary to seal the tanks prior to usage with a demersal species, which is a species of fish that occupies the bottom of water column. The next potential stressor is water quality. In a recirculating aquaculture system, water cycles through each tank, gets filtered, UV treated, and then returns to the tanks. But the systems we were using weren't designed for fish of this size and quantity. For context, the fish that were previously in these tanks were either tilapia or bluegill. The issue identified to be limiting water quality was the mixing of the filtered water and wastewater. So if you look at the diagram, the water will go into the tanks and then go back out. And then it would go into the sump, which holds the water before it gets filtered. But after it gets filtered, it goes back where the dirty water is. So that reduced the effectiveness of the biofilter. And because of that lack of separation in the sump, the water in the tanks looked like this. Not very clear. It was very hard to be able to visually see the fish, and likely had a lot of waste products in that water as well. After identifying the issue, we added a separate sump for the filtered water to go to before being treated with the UV light. And then after adding this second sump, the water looked like this. A drastic change. I'm sure the fish were a lot happier in this water than they were the previous. The next potential stressor I'm going to talk about is density. Since this species is demersal, like I mentioned earlier, it only uses the bottom portion of the tank. Thus, it reduces the available volume of water that's occupied. So normally I would look at the volume of water in a tank and think about the size of the fish and calculate how many fish could be in the water based off of the volume. But because this is a demersal species, it is necessary to look at the surface area of the tanks and make those calculations based off of that. The next potential stressor I want to talk about is feeding. We had tried feeding a variety of frozen food types the local aquarium store had with no success. But while I was working on writing my literature review, I saw a paper by Booth et al. 2013 that used pit tags and antennas and found that Sonora's suckers forage at night. I had been feeding the fish whenever I was working at the greenhouse, which was always during the day. So I started feeding the fish at night and they immediately started eating. So to sum up what I talked about, we learned that linear flow to replicate stream environments is important. It's important to ensure that there is no exposed irritating surfaces for demersal species and to not just assume that existing systems will work. When thinking about the density of demersal species, the surface area, not the total volume, should be used. And feeding at times aligned with the species' natural behavior is important. So at first, when the fish started dying, I felt like I was the failure. I felt ready to give up on grad school for a second time. But through the support of my advisors, my lab mates, my friends, and my husband, I carried on. After addressing the previous issues, we got more fish. And while attending the National American Fisheries Society meeting in Grand Rapids, Michigan, the new fish we had just gotten died as well. I had to change my presentation last minute from a happy ending about getting new fish to a work in progress. But I was honest about what went wrong and vulnerable enough to ask for assistance. At the end of my presentation, I received lots of questions and suggestions. People came up to me afterwards to offer their help. And because of my vulnerability about my failures, I was able to learn new things that has helped advance my research. Oh, wait, hold on. Yeah. So what are my conclusions? Here are the things I want you to remember about failure. Failures are inevitable, not inherently a bad thing, and are opportunities to learn. With a shift in perspective on failures, you can open yourself up to new opportunities. So with that, I want to say thank you to Field Inclusive, and thank you to all of the members in the audience for listening to me talk. My name is Taylor Saucier, and you can find me on Twitter and Instagram at Taylor E. Saucier. And if you have any questions, want career advice, I'm not an expert in that. I just bared my soul about all of my failures. You can feel free to email me. I will happily help you in whatever way I can. So that's it.
Thank you, Taylor. This was a wonderful presentation on your fieldwork fails and how you turned them into successes. And I would like to thank you once again for sharing your experiences. I would now like to open it up to our audience by taking some of the questions already placed in the Q&A chat. Again, if you have a question, please use the Q&A function and share that with us. So I'm going to go ahead and start with the questions. So the first question says, how has the support, for lack thereof, of your past supervisors impacted how you feel like you've been able to learn from failure and improve practices for the future?
So in the first time I attempted to go to grad school, I had a great advisor then as well. And I don't credit him at all with my failures and my inability to complete my time there. I think that I had to learn how to ask for help because advisors are usually very busy and don't have a lot of time, supervisors as well, and the job. And so I have had to learn as part of becoming an adult to ask for help when I need it. And so when I had my job, I was struggling with some of the aspects of the fieldwork there. And so I started asking, the HR person for help, and they were able to help accommodate me with some of the issues I was having. And then my current position, my advisor has been really great. And he has been more proactive in encouraging asking for help, as well as knowing that things are going wrong and things are failing. And he has reached out to me to make sure that I know that I am not the failure and that this is normal and are all part of the process. So I definitely think that having a great supervisor that is proactive can make the world's difference. But just because a supervisor isn't proactive in anticipating your troubles doesn't mean that they're not helpful and can't be helpful. I think that a lot of times you need to advocate for yourself, which can be very difficult and is definitely a skill that has to be learned and practiced. But yeah, so I definitely think that both my relationship to the advisor or supervisor and their relationship to me has changed. So that's just one more thing on that. That's why it's, to me, very important when you're looking for supervisors in future positions that they have a style that is adjacent to how you work, because some supervisors are more proactive or are more hands-on and some are more hands-off, and that works better for other people. So making sure that you're compatible with who you're working with is important.
Thank you for sharing. Okay, the next question says, thank you so much for your vulnerability and sharing. You mentioned an ADHD diagnosis. Have you found that it is best to disclose having ADHD to your supervisors? When might it be best to do so?
Okay, so that is something that I am also currently working on. I think it's very difficult to be vulnerable about mental illness because there is such stigma around it. And I definitely think it depends on your relationship with your advisor. I know my advisor, and because I had a graduate student that has been with him longer than I have, she was able to let me know that he is a safe person to be able to discuss that with. And so I have been able to share with him that, yes, I have ADHD, and that is something that will impact how I work, and that I will probably need, accommodations and things like that. But there are also people that can negatively impact your relationship with them. So I think being able to find people that you feel comfortable sharing that with is important, but making sure that they are going to be a safe person is definitely advised. So I hope I answered all of that.
Thank you, Taylor. Okay. Next question says, what inspired your interest in fisheries research?
So I originally started out undergrad as a biochemistry pre-med major. I had done EMT research or EMT training in high school. I was dead set on going in the medical field until I started taking all of those biochemistry classes, and I never saw the light of day. And I knew that I loved being outside. So that was something that was important to me. So I decided that I was going to switch my major, and I just was at school. So I just kind of looked at all the majors offered, and I found wildlife, fisheries, and aquaculture. And I did not grow up fishing very often. I had a couple times, but it wasn't a big part of my life. I just liked being outside. So I started taking these wildlife and fish classes, and there was a position available to help a graduate student out with their fisheries research. And so I started helping her out. It was with a cute little kit. It's called a Gulf killifish. And they're adorable little fish that I fell in love with. So I think my love of the outdoors, and then just my first job happened to be with fish. And then I just, every job after that kept being with fish. So
Thank you for sharing. Okay. So can you share any valuable experiences or lessons you've learned in your field?
let's see. In my field and in the natural resources field in general, I think the most important skill to have is to be able to be adaptable. Um, a lot of things can go wrong, like the whole theme of this talk. And so being able to work with changes as they come, um, because you're going to plan everything out to a great detail and research and with field work, but inevitably something's going to go wrong. So being able to work with that and adapt and change, I think is very useful.
And thank you for sharing. Okay, just a couple more questions
Yeah.
here. All right. Next question says, do you have any advice that you would give to someone who is interested in your field?
My advice is to try to get as much experience as you can. Obviously paid experience is preferred and recommended. But if it's something you love doing, then I think that, it's great to try to find those ways to get involved in any way possible. But I know that universities always have graduate students, and graduate students can always need more help. There's not enough time in the day for a graduate student. So just like reaching out to the graduate students at your university and finding out, like, hey, is there anything that you need help doing? Can I just accompany you on your field work or things like that? Most graduate students will be happy to have an extra hand. So
Thank you for sharing. All right. Next question says, do you ever feel a fear of failure? Does it decrease your motivation or make you overly cautious? And lastly, how do you focus on your current task and not worry about any future issues? A lot of questions packed in one. I'm sorry.
no, I like this one. Do you ever feel a fear of failure? Yes, all the time, constantly. That's part of why I was really happy to be chosen to give this presentation, is because I have had so many failures recently, and it hurts. It doesn't matter how much you try to reframe your thinking on failures, it still makes you feel bad. So yes, I every night I go to bed, I am worried that my fish are going to die again. Um, and that will be another failure. Um, and does it decrease your motivation or make you overly cautious? Yes, sometimes. But like I said, this is something I am currently trying to work on. Um, and letting me use that the previous failures to motivate me instead of letting it decrease my motivation is trying to flip it on its head. I am a very anxious person in general. So it does make me overly cautious, and I have tried to reframe my anxiety and overly cautiousness into a positive. So with work doing culturing fish, if I am cautious about the fish and I am on top of the water quality measurements and all of these things, it makes me a better, more dedicated scientist. And I am able to give my all easier to the field because it's something that I care about, and I don't sleep well at night if I know that the fish are not okay. And then how do I focus on my current tasks and not worry about any fish future issues? I think it's just you have to reframe things in your head, and that your current tasks are going to help prevent future issues. And so if you are doing the things that you're supposed to do, and you are, on top of things and taking care of all the steps you are taking, that if something does go wrong, it is not your fault, because you are doing what your best, and that's all you can do. So I think that just focusing on trying to do things to the best of your abilities, and then if something does go wrong, that it's okay, and you can accept it and move on.
Thank you for sharing, Taylor. That's great advice. Okay. The next question says, how have you been able to adapt to fieldwork and research as someone with ADHD and mental illness? What are some of the biggest challenges?
The fieldwork part was definitely really difficult. At my last job, we ended up doing fieldwork 75% of the time. So it seemed like 2 to 3 weeks every month I would be out in the field. And that was really difficult for me because, like I said, I rely a lot on my support system. And so when I was out in the field, I didn't have access to some of the supports that I had at home. Um, but I think finding support through your coworkers or lab mates or whoever it may be, can really help. And I think that for safety reasons, when you're going out into the field, there was a previous question about talking about your supervisor about your mental illness. But I think it is important to be able to disclose your mental illness issues, with who you're going out into the field with for safety reasons, especially if it's like something that may impact your ability to get the job done. And so I think that having your coworkers be someone you can rely on and work with, is the best support that I've had. They all know I have ADHD. Half of them have ADHD as well too, so we are able to help each other overcome some of the barriers that we have. The biggest challenges, I think, is starting that initial dialogue. Like, it is so terrifying to, like, you have this dark secret, and then to have to disclose that to people that you meet, even though it can usually be this very beneficial, helpful thing, there's always that fear that they might react wrong, like not wrong, but in a negative way. So I think that the biggest challenge is starting that dialogue, but I have had really great experiences once I've opened up about my mental illness, and shared it with the people that I work with. So
Thank you for sharing. Okay. This next question says, what was your most challenging research obstacle and how did you overcome it?
most challenging research obstacle. Um, I want to say the most challenging research obstacle specifically I've had was when the fish died. I didn't go into the details of numbers, because I was a little ashamed, but we had 48 fish, and from that cohort, only 2 survived. So it was huge mortalities, and we tried every available treatment possible, and nothing seemed to stop or slow the mortalities. And so that was something that was hard emotionally and was hard research wise, because now I finally got fish that are surviving and are happy and thriving. But that took me a whole year of my master's project to be able to do that. So it's kind of set me back some as far as like research timeline stuff goes. But I feel like overcoming it was just perseverance, of just having to keep going. I think once you think about how far you've come so far, and how difficult it would be to go back or start over, having done that once before, it makes it a lot easier and puts everything in perspective about like, I worked hard to be here. I am capable of doing this. I would not have been selected for this position or this job, if other people didn't see that as well too. So trying to think about like how other people view you as well, I think is something that helps put your mind in perspective.
Okay, thank you for sharing. I think we're just about out of time. If no one else has any more questions, Q&A box is still open, but all right. So thank you for sharing, Taylor. We're out of time today. On the behalf of Field Inclusive, I would like to thank Taylor once again for joining us today. And we thank you for the work that you are doing and continue to do when it comes to being an inspiration to others in the natural science field, and for sharing your experiences. Again, we thank those of you who joined us today. We will continue these conversations as we further our initiatives and work when it comes to amplifying social field safety issues, as well as amplifying minorities in STEM. Please be sure to follow and interact with us on all of our social media channels, including Instagram, Facebook, Twitter, and YouTube at the handle @FieldInclusive. Please also be sure to visit our website to learn more about our organization and ways that you as an individual or organization can support us. Be sure to check out the rest of our virtual Field Inclusive Week events, and be sure you are following us on all of our social medias to hear about and enter our daily giveaways and fun social media challenges. Tomorrow at 3 p.m. Eastern, we will hear from Ali Putnam, a PhD candidate in the Organismic and Evolutionary Biology program at UMass, and Grace Castleberry, a fisheries biologist and postdoctoral research associate at the University of Massachusetts Amherst, who will discuss the topic of building accessibility into research protocol. We hope you all enjoy the rest of your day, and thank you again for joining us.